Squares by Yahoo, Yahoffice of course, and Brandon Finch.
Characterizations of a square. A square is a parallelogram, a quadrilateral, a rhombus, a rectangle, all by definition.
Properties of a square. Squares have all four sides equal, diagonals that bisect its angles, each angle which is 90 degrees, and diagonals that form four isosceles right triangles.
Square equations and proofs. The area of a square is calculated by multiplying the length times the height, or the length times the base. The proof is, if a quadrilateral is both a rectangle and a rhombus, then it is a square.
Example number 1. SQUA is a square. If one of the triangles shown in the figure is chosen at random, what is the probability it is isosceles? Now first, you look at the given right here. Now, we look at the square that has two diagonals, which in this case would be QA and US. Now, we know from the properties of a square that its diagonals bisect its right angles, forming two congruent 45-degree angles. Now, we look at that from here. We look at A or QA, if you want to call it that, bisecting angle SQU, right here. Now, that would make two congruent 45-degree angles, here and here. There. And then, since we did it here, we also have to look at US or SU, bisecting angle AQU, AUQ, which would be right around here and here. Also making 45-degree angles. Because now we have two congruent angles, we can now apply the theorem. If congruent angles, then congruent sides. Now I will show it. If we apply this method to the remaining three right triangles, we will then have three isosceles right triangles. Now that we have congruent sides, we have isosceles triangles. Therefore, our probability will be
Example 2. Swag is a square. If the length of SG is 2, what is true about the length of SW? In a similar method to the last problem, we are going to use the diagonals. The diagonals split the right angles into two equal congruent angles of 45 degrees. We will use the same theorem if congruent angles, then congruent sides. We will assign Z to be the coordinate here. With the information we have now, we know that triangle SZG is congruent to triangle SWZ. Using CP/CPC, the value of SG is the same as SW. Therefore, Y equals 2. The shorter method of doing all this is remembering that all the lengths of a square are equal.